Alright, I decided to do a homework section video for 12.5. I'm going to do two questions for you, one kind of a precursor to the other one. Ignore this one for now. Let's focus on this one. This is one of the homework questions. You can see it's directly out of the homework. And the exponential model A equals 257.7 e to the 0.009 t describes the population A of a country in millions t years after 2003. Use the model to determine when the population will be 267 million. First of all, you can ignore the millions and just use 257.7 and 267. I'm just going to graph this. I'm going to go to Desmos, type in y equals this thing, and a second y equals 267. And when I do that, I can see, and I had to adjust the window, play with the window a little bit, but here is the population growth growing exponentially. And then this thing right here, just this y equals a solid line, where those two intersect, I find out exactly what t is. T is 4. Okay, so if t, and I just click on that to find it. You can click on things, you can click on that point, and it just pops right up. So I find that t equals 4. Well, if t equals 4, what does that mean? That means t years after 2003. 4 years after 2003 is 2007. So our answer should be, when will the population be that? It should be in 2007. If it's not, I will eat my socks. Sweet, it is correct. So then I move on to my next question. And the next question is this one here. In 2000, the population of a country was approximately 6.07 million. And by 2040 is projected to grow to 9 million. Use the exponential growth model here. So t is the years after 2000. So when t equals 0, that's my y-intercept. That means my a sub 0 value is going to be that initial amount of 6.07. Okay, I also know that when t equals 40, 2040, 40 years after 2000, that my population is going to be 9. I need to use that information to find the value of k, because k is that growth rate. All right, so I know this, and this. At a specific time, the population will be this if it started from here. Plug all of those into this. The only variable you will have left is k. My population will be 9 million. When it started at 6.07 million, with some unknown growth factor after 40 years. I need to solve this for k. We talked about this in section 12.4, how to solve things like this. We first of all isolate the e by dividing by 6.07. So e to the 40k equals 9 divided by 6.07. I'm going to natural log both sides. Natural log of e to the 40k equals natural log of 9 over 6.07. By natural logging, I bring the 40k down, and hopefully by now you know that the natural log of e is 1, so it drops away. Equals, prove it in your calculator if you need to, equals natural log of 9 divided by 6.07. Now I will divide by 40 and find out that k equals natural log of 9 divided by 6.07 divided by 40. Let me go to the calculator real quick to see what that equals. The natural log of 9 divided by 6.07 is that divided by 40 gives me 0.009846. Let's go back to the problem. It says the exponential growth model round to 2 decimal places. 2 decimal places means 0, 1. That's my k value. So my growth model is going to be a equals my initial of 6.07 times e to the k t. I can type that in right here. 6.07 raised to the 0.01 t, and that is correct. Now I can use that to figure out when it's going to be 11. Go back to Desmos. Go back to Desmos, type y equals 6.07 to the 0.01 x, not t. Desmos doesn't like a and t, it likes y and x. And then type another y equals 11. Find out where they intersect. Whatever you get, add that to 2000, and that will be the year that we hit 11 million. Wow, I hope that you can go back and scroll around on this if you need to. Again, there's 12 questions of just straight word problems. Feel free to put me to work and email me if you have any questions on these. All right, take care.